Learn. I'm G. Trulia. I'll be reading and monitoring the chat today. Swede Oun will be doing the commercial vehicle diagnosis.
Yeah, you can zoom it over the. Yeah.
Journey continues. This is a great one on electric. Swede, take it away, my friend.
Thank you, G. Guys, I truly gotta. Hopefully, everybody hears me now and sees me. I really apologize. It's, you know, I hope the rest of my little lunch and learn doesn't go that direction. I'm going to try to rush through a lot of stuff because I want to get into a live board situation here. And by the way, thank you guys again. I noticed by the names a lot of you have been before, so I'm having a hard time looking at the chat box, but I'm glad that G is over there. So what's going to happen is when I get into this, and if you guys got some questions and stuff and I can't catch it, G is a master on electrical stuff. So I know you guys are on a time constraint. Probably if you're like me, you're working someplace. So let me get right into the seminar and I'll walk through everything. Hopefully, let me know everybody's still okay. Yeah, this is going to be recorded.
Swede, they're good?
Okay. Let's go into it, guys. You know, it's been a rough week for me too, guys. I'm from the Buffalo area, by the way, just so you know. And I acquired a couple of Amazon contractor stuff, and we had an overnight freeze and stuff. That's all I've been doing was changing wiper motors and stuff. Go figure. I'm preaching to acquire. You guys know what it's like. You get a customer come in, my wipers don't work, or they're stripped or whatever. It's like, hello, shouldn't you have kind of like released the wipers from the icy windshields? But you know where I'm going with this. So anyway, let's get going here. Thank you, Dorman, by the way. Don't even worry about me. You're going to have some handouts. Every time I do this, I'll say, you know, more important is, you know, what you learn from here. So, and I'll get into it. So now, I'm going to make this a real quickie. This is a little bit of a war story. So, I was doing a brake course a few years ago. Part of one of the modules, it was a 2-day brake course, and one of the modules is ABS. So I go into this class, and it was out of my area, somebody else's facility, and people from different shops. So the shop I was in with, the guys threw at me, it says like, you know, I told them we're getting one of the modules ABS, and everybody threw it at me and says, oh no, we're cool with ABS. I got a huge box that, you know, gives me codes, does this and everything else. So basically, I told the guys, I says, humor me. I says, when I teach you ABS, we're going to do the fundamentals because not everybody has software and so on. And, you know, just bear with me. But they kept throwing this box at me. So what happened was I was scheduled to, I did another brake class next week. So, but in between the 2 weeks, all of a sudden I get a phone call from this particular company. This is early in the morning. And the company says, listen, we got a guy, he's got an issues with the ABS, and the brake lights come on, or the ABS comes on when you step on the brake lights and everything. So I says, okay, where is that? He says, he's at a truck stop. I says, well, you know what? Give the guys a chance, you know, give them a chance to figure it out. I know you're in a hurry. Driver's probably in a hurry, get to their destination. And the person on the other end says, hey, listen, he's been at the truck stop for 5 hours now and they can't figure it out. I says, well, I'll let you, you know, if you want to send them over, go, you know. And the other thing, that same person says, by the way, it was in our shop for 11 hours, you know. So I says, oh, okay, send it over. So anyway, make a long story short, that driver comes in with the truck and he's over there, blah, 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 it ain't working this. And I mean, you know, he's not taking it out on me. So I says, just chill out, let me get at it. And I got my son, because I figured it's easier. Issue is in a trailer, one guy front, one in the back, instead of walking back and forth. And I told the guy, I'll have you out in about 15 minutes, half hour. He says, well, it's impossible. So I get in a catwalk and I start doing basic checks and stuff, and the guy says, listen, they already did all that. I says, I don't care. I says, you know what, do me a favor. I says, just get out of the cab. You keep interrupting me, I'll get you going. The bottom line is, because I'm really on a time crunch right here, but bottom line was it's one of those Contintues. If you look over here, what happened was when they had it in the shop, somebody changed these wires, and guess what? There was a strand touching between the red and the blue wire. So I got this done. Out of there, it wasn't even half hour, to tell you the truth, you know. So I let the guy rip and everything. So I go back over there next week, and this is what I showed him. I took a picture of this. I told the guys, here's your freaking box. Excuse my French. I says, so, you know, so much for, you know, all this big fancy tools and everything else. The idea of this, my big box is my head fits in here, okay? And that's my brain. God gave you the best tool that you ever had. So let's move on. Okay? So, gee, by the way, too, as I'm going through this, because I'm going to go awful fast, and you'll notice when I get into my little board we're going to work with, there's going to be a lot of, possibly if there's any questions, do me a favor. I can't answer everyone because I'm going to be really rock and rolling. But you got one of the greatest guys out there, instructors, trainers out there, shoot it in the chat box. And if you have any specific questions, like on voltage drop, if I'm not catching it, because I'm on the fly with this thing, G definitely can help you out with that. So I'm relying on my best friend G over here to work with me. So let's get on with this. This slide here, and I apologize if I'm going to go a little fast here. The topic here, it says right up on top, everything starts here. The vehicle battery provides all electrical energy when the engine's not running. If you didn't know that, the alternator, it's really a generator, provides the electrical power when the engine is not running. Of course, you know, you want to turn the radio on and the heaters and all that stuff. But the big priority of this battery is you ain't going anywhere unless that engine starts. And this guy is going to throw out all the amps it can to crank that engine over, okay? And to do that, it definitely requires good amperage, good cables, good connections, okay? So I put on here, note, available voltage of battery must stay at a specified point while supplying the required current for starting. You get into some of these trucks and everything, and you're cranking your cars today, you don't see too many kind of problems with batteries. Those kind of ended quite a long time ago. I can get into the history of the batteries and everything else. But you get some of your cars over there, quarter of a crank of the turn, and I'm exaggerating a little, but your vehicles start. The truck's still gonna have to crank, get the compression up, and by all means, I gotta tell you, nothing like it was in the day, but you're still working a little bit harder when it comes to these diesels. So, you know, now which way does electricity flow? I hate to say it, I'm doing it fast, but G's got some good electrical courses. You know, if you ever want to go through it, it'll slow things down. You know, I do electrical courses, but anyway, everybody's comfortable with conventional theory. That is okay, okay? However, in reality, electrons do flow from negative to positive, and if I was doing a regular class, we can do the whole theory and all that stuff, okay? But I put this in here for one reason. So if you believe me that electricity flows from negative to positive, you see where my arrow is at ground? We do not spend as much time as we should on the ground. And in reality, when electricity flows, it's just so fast that do you really care which way it flows? But realize that this ground is so important. So that's all I'm trying to convey with this. And you know yourself, if you're working on a lot of these vehicles and everything, guys, what are your biggest problems, right? Connections, grounds, that's your biggest problems, which will lead us into voltage drops. So now, case study, whatever. This just happened a couple weeks ago. Diagnosed by following a set of procedure. Did we get lucky occasionally? And that happens to you guys too. So I had this vehicle come in. It came in towed with a complaint of intermittent no start. This was a smaller vehicle, okay? And I think it was a ProMaster, whatever it was. Some other shop had already replaced the starter and battery. This complaint was we have intermittent problems of starting this vehicle. So they figured rather than get stuck again, they towed it to a shop. So now my son Brian did the basics, including checking connections. I mean, after a while you learn visually to go, after that stuff. Check the ground for tightness, okay, and that's key for it. It was tight, okay, and we see a lot of these with some of these Amazon vehicles. Everything seemed to be okay. Next step is isolate the starter circuit. Okay, starting with the control circuit, and basically if you zoom in over here, okay, I got a little relay thing that, you know, I can click it on. I'm going in a control circuit, okay? So he happened to use the relay to also crank the starter just to see, are we having control issues, but however, because he was doing it from the hood, he got lucky. So I'm going to turn on a slide here real fast. On the next slide, we're going to try to catch it here. Okay. Now zoom in. You got to look over here. Whoop, you just had a spark.
No, down a little.
It'll be on this side. There you go. Like lightning. Hopefully everybody sees that. Okay. Try one more time. There you go. Lightning again. There you go.
Good one.
Okay. So anyway, what happened was the problem wasn't at the connection. It was a little bit higher above in a wire, but the wire was close enough to a ground on the engine, okay? The engine itself, you know, as a ground. And when the conditions were right, it acted almost like a spark plug. It would jump the electrodes and stuff, okay? So we were lucky this time, okay? We disconnected the wire, repaired the wire, and of course you're there anyway, clean the ground connection, reconnect it, started every single time, okay? Customer driver happy because the truck is out there earning money for the owner. So I put it in here as like, was it luck? Was it diagnostics? You know what, in reality, and it happens to all you guys out there, it was a combination of starting a proper diagnostic procedure, having a knowledge of the starter system, and yes, that led to the lucky break of visually seeing the issue. The spark verified the problem location, okay? Once in a while, isn't it nice to have stuff fall in place, okay? Unlike what we had this morning, okay? So, oh, thank you. I just happened to look over. Somebody said, please relax. Never mind rushing. Take your time. We need to make our time here to be quality time. Very, very nice. Guys, boy, I really appreciate that. Takes the pressure off of me, okay? So thank you very much. You know. So what's inside a typical battery? Each cell has alternating positive and negative plates. Plates are separated, insulated from each other, preventing short circuit. They're immersed in an electrolyte solution. However, each cell does have 2.5 volts. So it's 2.5, 2.5, 2.5, 6 times 2.5. What do you got, guys, right? 12.6 volts, okay? Now, this is important for you guys in the trucking. Inside, each cell is connected. They're connected in parallel to increase battery capacity, amps, okay? This is the same concept when you have multiple batteries in a truck. If you're going across 12 volts, 12 volts, 12 volts, and you put them in series, okay, you can add them up. Think about in a day, 24 volts, 2 12-volt batteries, right? However, you got 3 batteries, 4 batteries, and you go in parallel, okay? Positive to positive, positive, if you got 3 batteries, negative to negative. You're still maintaining 12 volts. However, you increase the capacity of this. Again, we're going back to think about starting these diesels in the coldest day in hell over here, you know, and wherever you guys are coming from. I see some guys from Texas, you know, you guys are pretty lucky. I shouldn't say that. I know watching the news, you guys get a lot of this, you know, snow stuff too once in a while, cold weather. Now, we went into these AGM absorbed glass mat batteries. They're used, basically what it has, you have absorbed glass mats that are used as separators between the plates. The electrolyte is absorbed, held between the plates by the glass mats. And basically you're eliminating the need for immersing the plates in large amount of electrolyte. The earlier batteries, what happened was, you got two dissimilar metals, okay? So every time you discharge, you're using a battery, okay? What happens is you would transfer, the sulfuric acid, and they would go into the other plate, and basically you got two similar plates. Well, that's not a battery. Battery has to have two dissimilar plates. Well, in the process with this electrolyte solution, okay, you have evaporation and so on, and you wind up having dry plates because, you know what? We didn't take care of it. We didn't open up the tops, we put water in and all that stuff. So we had issues. So that dry stuff would go to the bottom, go to the bottom, go to the bottom. Before you know it, you got a little bit of shorting going on, and there's your battery. So the next step was try to seal the batteries to prevent that escape of these, vapor in a vapor form of the solution. And, we progressed and progressed and progressed and progressed. So finally we got to this stage here with the absorbed glass mats, okay? They are good. Now I want to point something out. Usually in your flooded batteries, your state of charge on a typical would be 12.6, just so you know. Kick it up a little bit, 12.8, okay? And this is what they look like, and they don't have to necessarily look cylindrical. You have some of them that they look square. But the big thing about this is if you have HEM batteries, typically you will find them someplace inside the truck. Okay, you can open up the seat or whatever. Oh, by the way, this is our real world here, guys, right? Am I right? This is what I'm talking about. If you don't understand how these batteries get hooked up, you better draw a diagram. Make sure you know where the cables go, because I've seen a lot of guys, they'll hook everything back up. It's like, whoops, and you get that oops moment, okay? Our world, guys. I love our world, okay? Now, watch this.
Basically, we're losing voltage in the connection somewhere. We have it between the posts here.
You zoom in a little.
So we have the connector here, stud here, nothing here. Scrape it down to clean metal, nothing.
Okay.
Have it here, but not here. And that goes through a cable down. Check engine light coming on for charging system.
Basically, this is what that voltage drop concept is about. You don't want to overcomplicate a voltage drop, and we'll do some live stuff over here, But again, instead of trying to kind of jump in, change the battery and all that, maybe changing the battery might have accidentally fixed that thing. But what if it was good battery and so on, and all it should have been was you had to do something with a connection here, Now here's another. See how dim it went? Test lights, we all use them, guys, but I wanted to make one point over here. Hey, how many volts are we seeing here? I don't know. Maybe it's one of those audible test lights that are 3, 6 volts, 8 volts, 12 volts, I wish I could invent one like that, Now, we are going to spend a little time. We're going to go on the board here. We're going to use some stuff with a digital volt ohm meter. When I'm doing, and when Chi does his classes too, we really do spend some time on it, because one of the questions I get in classes is like, this is great, and I make sure everybody brings their digital volt ohm meters, and they're from all over. And I'm not trying to sell digital volt ohm meters. Actually, they're multimeters, okay? Not digital volt ohm meters. They do more than that. But regardless, okay, classroom settings sometimes are very nice. When you sit there, you get to see what somebody else is using, Maybe you're in the market for this brief period of time. What a place to say, like, you know, ask somebody, what do you think about yours? This sucks. What do you think about your, oh, the greatest one I've ever had. But you know what I'm saying about networking and stuff. But regardless, if you're purchasing a meter, you need to ask yourself a few questions here. What do I want to know when I hook up a meter? Is it safe to use on any system I will work on? Guys, we're getting into, you know, hybrids, pure electric vehicles, and so on. You know, and that's not really, it's a good question. But also, what are my anticipated readings so I won't damage the meter or the circuit I will test? So, for example, your flukes, most of the meters, you're fused for 10 amps. Eh? So if you start exceeding that, on a fluke, for example, that fuse gets very, very pricey. I'm just throwing little things out there, guys, for given the amount of time we have, you know, for lunch and learn. Look, network with other people to get real-world input on meters they use. And by the way, price isn't everything, okay? And, you know, Ryan Connor, by the way, I see you out there. Thanks for the email to you and other guys that have questioned about how to, you know, is this going to be recorded live and everything? Because I know you emailed me, or you through the Facebook, you wanted to get a lot of your guys involved in looking at this. So thank you, Ryan. I just had to mention that. Now, Fluke does a very, very nice job. And again, if this was a regular electrical class, we would slowly, because all meters are somewhat similar to this, okay? And you need to pick on your own meter, you know, what do you want? There's so many good stuff in here. There's Minimax in there, you can range, manual range, automatically. You know, the diode tester here is very, very important, because if you're going to check diodes, one-way electrical check valves, this has to put enough out over here. You see that little symbol over here, the diode right here. I'm hoping I'm pointing it right direction. Diode test position. You got to give it that 0.6, 0.8 volts to turn that diode on. So those are things you got to know. Now these are bad. Once you good, excuse me. You got to get comfortable with this stuff. Now there are meters out there that you'll have, like for example, in resistance or volts, you know, 200, 2000, so on. Those takes a little bit of a learning curve, you know, because you can go into a well or whatever. But the biggest thing I try to drive home to everybody is right here, these pockets, okay? You got the amps and volts here. What happens is in the classes, and I know G does the same thing, you break into the circuits and stuff, and if you're not comfortable with that, you need to drive it home. And I try to drive it home my classes, because I actually haven't built circuits and stuff, is like, listen, if I ask you to take a amp reading, make sure you pop this out of here and put it into amps, move your dial to amps. But however, the next question I might ask you is, listen, I want you to do volts now. You got to remember, pull it out of this pocket and put it in this pocket again. Because what happens is, through the course, some of the circuits they build, all of a sudden, it's like, I'll get a guy, it's like, nah, there's something wrong with the circuit. I'm not getting a reading. Chances are pretty good at one time you blew the fuse, because when you go into your amps and you put this meter in series, okay, this guy here becomes an electron counter. It becomes part of the circuit, okay? So, and we can do a lot of more stuff. This is a continuous, you know, we can revisit all this in future lunch and learns. Real simply, because I mentioned in the heading over here, what are we trying to do? We're going to try to cover some voltage drop, okay? This is a parallel connection. The meter is placed across the load. The number of volts measured will be available voltage or voltage consumed by that load. So if this was a 12-volt battery, to be honest with you, if everything is perfect here in this circuit, this one single load should take that source voltage, okay? Your electrons, by the way, still go. They start from the source and they go right back to the battery if this was elongated, okay? And of course, in here, you can break in, take your amp reading, and so on. Now, but let me back up. For example, we're going to get into that too. So if I had 11 volts here, okay, that means someplace I lost a volt. It's someplace, and this is where voltage drop becomes kind of important. Now, current, I already mentioned you need to break into the circuit. The meter becomes part of the circuit. It becomes an electron counter, okay? I already mentioned know the anticipated amp reading, okay? It does have limits, okay? Some fuses can get awful pricey, and then of course, you know, I highly suggest get a little jumper wire with a fuse. Let that little El Cheapo fuse blow before that one blows, okay? Measuring resistance, of course, and you know what? Me personally, I don't really use that portion of my meter that much. It's okay. Gives me a quick kind of like okay. I do not have continuity here. Okay, if I can reach one end of the wire to the this verifies that I got no continuity. But I love the dynamics. I love using the amps, and I love using the voltage. But regardless, okay, the meter itself supplies the component with a known amount of current. The meter is going to calculate the resistance, okay? Make sure you have a good internal battery. Last month I did have this on. This load could be anything, guys. You know, whatever comes into your mind, a bulb, a motor, a solenoid, whatever. We need to control something. You know, we can't just, you know, hey, hook a wire on and this is constantly on. Physically, somebody's got to do this, or the switch here substitute the computer in there. This could be the computer. A computer is just a switch. That's all it is. And of course, we need to protect our circuits here. So, but in your handout, visualize it. Visualize it. I'm going to put my meter here. What do I expect to see here? Of course, you're going to expect to see your source voltage, whatever it is. Now, if I put it here, should I see voltage here? If I go on this side, what should I see? If I go on this side, and so on, you know. So sometimes use it as a tool to visualize what you're trying to do. 3 type of issues we're going to run into. This is open circuit. This is a no-brainer, guys, okay? You just have to go in there. Again, going back to a previous slide, I got my source voltage. Do I have voltage here, voltage here, voltage here? Whoop, got nothing there. So again, start thinking about that kind of stuff. Short to ground, I got to tell you, that short to ground, if we're... Somebody might misconstrue me, but you want to find a short to ground, you know, pull the fuse on and put a bolt in there, look for the smoke. I'm just kidding, guys. I'm kidding, guys. I don't want anybody go back. Swede says, hey, this is the way to look for it, you know. Shorts are hard to find, especially you guys that are working on tractors, trucks, tractor trailers. You're more prone to run into wiring. We do that every day, you know, cut a wire, add another section, cut a harness, add another section. Think of the environment, these components, these lights, and everything is in, the wiring. I mean, this truck is going down the road. You know, I see a lot of guys from Ontario, Canada. You guys know what I'm talking about. I mean, that salt and the calcium chloride and everything else they use on the roads. I find that kind of looking visually, the probabilities, the possibilities, and I've been very lucky just visually. It's a little bit more time consuming maybe, but it sounds more time consuming. I see guys over there trying to do this, going there, spend hours, where in my mind it's like, okay, I'm going to go buy this frame here. Chains are pretty good. That's where I'm going to have a short, and sure as heck, that's where it is. Don't forget, how about these guys that put a new light on the marker on top of the box over there? You know, change the light or something. And you're over there with a drill going, putting that screw in. Quite often, guess where that screw has gone? But again, this is looking at common sense. So let's go here. How about short to power? How would you find these types of issues? Usually caused by melted insulation, insulation rubbed through, causing 2 circuits receive power. It actually could happen inside the solenoid and coil. okay? Those wire wound armatures, okay? And if that happens, you could possibly eliminate a portion of the coil. So now, every component has a designed resistance in there. So some engineers decided, I gotta have X amount of coils in there, because you're working with Ohm's law, okay? You're working with Ohm's law. So back up a little bit, Bobby. Back the camera up a little, okay? So if this was my resistance here, you know, it's stupidly simple. Resistance is high. This is my resistance. Resistance is high, current is down. However, if resistance is down, current is going to go up. Well, if you brought the resistance down, what do you think is going to happen with that current? You could affect your PCM, BCM, and so on and so on. And this is why we say that if you change the BCM, any kind of a controller, and if there's solenoids involved in there, make sure you check that solenoid. There's nothing worse than changing the computer. Okay? You put a pricey computer in there, and guess what? You're back to square one again. Now, a lot of the computers, they possibly might have a overcurrent, over voltage protection internally, but do you want to take that chance? So, now, voltage drop, we're going to do some of this stuff real fast. Keep it stupidly simple, okay? So you hooked your voltmeter here in parallel. This is your load. Watch as you read. If this is 12 volts and you turn, by the way, you can't do a voltage drop unless you turn it on. Very, very important, okay? So keep that in mind in case I forget to mention. You turn it on, this should use up source voltage, right? So if this was 12 volts and this says, I'll pick something stupid, 7 volts, okay? 12, 7, what do you guys got left? 5, right? 5 volts. Somebody stole the 5 volts. Well, then you go looking and searching for it, okay? You do a voltage side, you can do it on the feed side, do it on the ground side, okay? Look at this. Good candidate, right? If this was a butt connector, ground side, single chassis. We use what we call a single wire, okay, ground in our system. And guys, that's the chassis here. Think of all the points where these grounds can go to, and keep it stupidly simple. So if all of a sudden we said we need 5 volts, if this comes up with 5 volts, you know what? I have an issue here. And then start working it down. Start working out. If you got multiple connections, keep working it down. Keep it simple. Don't overcomplicate it. So now, reason I'm doing this, okay, I can spend quite a bit of time with a relay, okay? A relay is low current controlling high current. So you need to get comfortable with a relay. Most relays, you'll have a little bit of a schematic over here, okay? And if you get comfortable with the circuits, if you flip over the other side, you'll see corresponding numbers over there, okay? 85, 87, 86, 30, okay? So what happens is 30 power, or depends on what you're working with, for high amperage circuit. That's your high amperage here, okay? Now you got 87A, normally closed high amperage contact. Maybe I'm trying to get that power, that high amperage is waiting there, but I want to send it out of 87A. I want it to go someplace, okay? Now, 87 normally open high amperage contact, 30 ground side of low amperage circuit, 85 power side of low amperage. So what happens is, you have, I got this wrong, guys. Sorry about that. Okay, I got that wrong. Just so you know, you can change it on there. Should be 85 and 86 for the low. Sorry about that, I was in a hurry. Change that on your thing, make that 86, okay? So what happens here is, this is my control circuit if you zoom in over here. Okay? So this is what I need to turn on. I turn it into electromagnet, and basically I bring that contact over and I let that power go out. And we'll do it a little bit. Sorry about that. I truly apologize on that. So, but you can see over here, okay, now I have this thing over here, it has that 86 and 85, and I use that on, off. I can check my control, and we're going to do that. So, see what we can do. Now, the board, I haven't showed you yet, okay? Zoom over to the other side real fast, okay? This board here, zoom out just so everybody can see, okay? This is the one we're going to play around with. And I picked this blower circuit here. We're just going to start using meters. I actually have a battery and starter that'll crank and start, okay? So the reason this is timed, I told G, this is very, very timely. Guys, this is a winter month. Man, you got to have that blower motor working, or you're going to be not a happy person if you get into a vehicle that it's 20 degrees out, the windows don't defrost and everything else. So we get a lot of those issues here. But, so go back on this one, Bobby, here, zoom in. Just so you know, okay, what happens, we have a sort of control. You have your different speeds here. You can zoom in a little bit more. You have different speeds here, okay. I got a low speed, I got a high speed, and so on. And what basically happens is you turn it all on, and if you follow this, you know, I'm fuse going out here, my little switch over here, and if you look down here, okay, there's little resistors here, 1, 2, 3. If I have to go through these 3 resistors, again, I'm dropping voltage. And eventually, when it gets to a motor, I'm not going to have quite the voltage that you would. You have a lower voltage, and of course, a blower motor isn't going to turn fast. So what happens is I turn it to my next with my blower motor with a switch. You know, I want it a little bit higher. All I'm doing is I'm bypassing one, do the math, do Ohm's law, okay? And now I'm going only through 2. My blower goes a little bit faster, okay? And once I've gone through all of these, I bypass this. When I go on high, forget about these resistors. I'm turning on that relay that we were talking about over here, okay? I turn it on, okay? You'll see over here, it goes over here, goes to ground. I turn this into a magnet, okay? And that pulls it over. And now all of a sudden I have everything that battery can give me goes through the blower motor, and voila, I have full-blown high blower motor working. Which, stop and think about it. If somebody comes in and says, I only have high speed here, first thing you want to do is head towards this section. Gee, I bet you it's my resistor combination unit here that's bad. All right. Whew. So, zoom in on this. Zoom in over here. Okay. I don't know how close you can see. There's a little mouse in there, guys, so I figured I'd throw that in there. So let's go in there, you know. Yes, I see the interesting enough 85 10 ground, but would work either way. You know, 86, 85 are the low circuit. But let's see what kind of trouble we can get into here. Now, you see this board pretty good. I have a battery over here, okay? I have a battery. I have it set up. I'm all hooked up to starter. I have a relay over here, relays, solenoid. I have a blower motor here. I have a switch. I turn it on, and now I'm going to crank it, and you'll actually hear it crank. I do not believe this. Gee, we could.
No noise?
We got chinks. You know, no. We'll see. I don't know. It's just like, you know, when I'm on a roll, when things go wrong, it goes wrong. I mean, you know what? We still got a little time. Let's see. You know, maybe it's something stupid. Okay. Let me see what we got here. You know, let me turn on my meter here. Of course, first thing I want to do is, you know, let me do it. I'll use a test light. I know we're trying to use meters, but I just want to make sure, because now we're pressing time over here, okay? Pushing time. Let me see if I got battery voltage. Did my light? Yeah, I got battery voltage. This I don't get now. I got nothing up here. Damn it. Excuse my French. Sorry. See, I'm so PO'd. I'm going to throw that Tesla right away, you know. So listen, guys. When I was playing around with it, everything did work. I wanted to show a voltage drop. So if you zoom in on here, okay, I just made a piece of wire in here because I was having trouble getting on the battery. So if you zoom in on the battery, I got the meter turned on volts, and I'm going to take this positive lead here, and I'm going to put it on my battery post over here. Okay, and then what I'm going to do is I'm going to put my other lead on the starter up here, where you can see the red wire goes up here. And if you zoom in over here, Bobby, zoom in on the meter. Okay. Now you'll see a little reading, 0.82. By the way, that's ghost voltage, you know. And let me see if I can turn it, make it a little easy. Yeah, that's a little bit better. Now I can wave this around in the sky and I'll get some voltage. That's not what I'm looking for. Ignore that, okay? I'm gonna crank it. Whoa, 12.5. I have a huge voltage drop. Okay? A huge voltage drop. Look, guys, I was messing with you a little bit. Let me do something. Let me see if I can put this over here. I'm going to put this on the post. If you can zoom in. Actually, you know, zoom in. I'm going to put one lead on the post. I'm going to put one on the cable. And I still got nothing. So that tells me between the post and my cable, I have a gigantic drop. So let me take this off real fast. Whoa, easy fix. This guy's gonna be happy. You know, zoom in while I'm turning this wrench. Okay. This is what I did. This board I actually built to use in classrooms. I did it for a tech competition, and I bugged so many things on this thing over here. So now, let's see if she starts. Wait a minute. Horn comes on, but it's not cranking. That does not make sense. I know my fuse is okay. Okay, it worked before. Zoom in over here by the solenoid. Okay? If I would have had more time, I would do something. Okay, if you zoom in on the solenoid, I want you to see something. Okay, you got hot going in here. You got hot going out to energize this, but to open up the passageway, okay, I got to turn on my switch, so I have a little power to turn this on. However, guys, that's wood. What happens is this also needs a ground. It's case grounded. Okay, so now if I do this, okay, and I give ground, now I can turn this into a magnet, open up my passageway, and there we go. It started. You know, probably, I was going to mess with you guys. I was going to say, hey, does anybody have a wiring diagram for a 1923 Oshkosh? Or so? Just kidding, guys, just kidding, okay? My point being is, if you have a good understanding of electrical, of how things work, you can figure this stuff out. But now, I have an issue over here. This thing here, okay, is my fuse for the horn. Take my word for it, it is. Okay, and there's nothing wrong with this fuse. Still working. Now what I did, guys, was that means that somehow when I'm cranking this over, I'm making a connection to the horn. Does that make sense? Okay, So now I'm going to have to try to isolate it, and I will do that real fast for the sake of time. Pull this off. Wow, couple of the little wires melted together. They were a little too close to the exhaust or to the engine. So let's see what happens now. That's the way it works, guys. With this relay here, I did something else just to prove a point. This is my typical relay over here. I took a relay, took the cover off. Zoom in on it. You can see I took the cover off. I'm going to put that in its place. And you know what? I must push on that contact just to show you. I need to turn into this magnet, transfer juice over to my horn. I could have a musical something here with Christmas songs if I had different sounding horns. Okay, so we'll do that. Now, I'm going to try something else here. I noticed something about the relay and ground and everything else. And whoever did that, you are 100% right, okay? Now, what happens is this horn is ground controlled. So I'm going to put my test light on the ground over here. Okay, zoom in so you can see it. I got that over here. Now, I don't know how good you can zoom in, but try to zoom in over here. Now that one wire, remember, okay, to turn on the relay so it allows the high current to go, I'm going to do this. I back probed it over here. I gave it ground, okay. Point I'm trying to make, guys, is this. Coming in from the back side. Now, what if this was, for example, the starter was controlled like that, and you had your buddy over there, say his hands are someplace, he's checking the belts or whatever, and of course you happen to be over there, well, hang loose here, you know, maybe the guy's trying to crank something to see, is it the motor that's kind of like, whatever the case may be, and here you are, you're accidentally probing in the back, okay, and all of a sudden, say if it was the starter, and the starter starts to crank by itself. So I'm just giving you a little word of caution over here. So let's see what else we can do over here. You know, let me turn this on. This should have been on. It timed out on me. Not necessarily. We're good with this. Okay, I'm still in the amp mode. So now here we have a blower circuit. Guys, it actually really works, believe it or not. I'll leave my ignition key on. I'm going to turn it on. And the reason you see the flag, yes, we are patriotic over here, okay? But also, in case you can't hear that blower motor working, I figured, how can I make sure visually people can see works? I'm going to turn it on. High, high. And hopefully you can see the flag. And, you know, I didn't realize there's so many people from Canada and stuff. Next time, you guys from Canada, I'll make sure that I'll put the maple leaf up there, you know. This way we're all in the same sync over here. Sorry about that, guys. You know, you're good. Yeah, I love it, love it, love it, love it, okay? Now, what can we do with checking here? I told you I like to check things dynamically, so I'm going to turn my fluke on. Okay, dynamically, that means I want to check, I want to make sure, I'm going to put it on amps. Okay, switch it over to amps, and he's going to hone in on there. I'm going to switch my pocket over here. Remember, I don't want to be the one, you know, do as I say, and you know, and I screw it up myself here. So what I'm going to do is I'm going to break into this circuit here. My meter becomes what, guys? We talked about that. I'm going to become an electron counter. Now, I'm going to put it in on the positive side over here. Okay. I hope all this makes up for the little delay we had here. Okay. So I'm on amps. Okay. You can see it pretty good. I'm going to turn this on. I'm on low. Now watch. I'm going to go into the next one. My amps went up. Okay. I'm going to go into the next one. My amps went up 3.6. And I can keep on going 5.2. It's auto-ranging itself. But you can see the amps went up every time I increase the speed. And there we go again. Every time I dropped the resistor, it allowed it to use more amps. To what?
Swede, we're good.
Oh, okay. I didn't know if something happened. So now, and believe it or not, I'm on the positive side, but I can do the same thing on the ground side. It doesn't matter. It doesn't matter where I do it. I'm going to take the ground wire off. Okay. And let me shut the switch off. I'm going to put it on the ground side. Okay. And I'm going to do the same thing. Exactly the same thing. The reading I'm going to get on the ground side is the same. The only difference is you're going to see a negative icon. And that's the beauty part of having a digital multimeter. The old analog meters, if I was to do that, they're polarity sensitive, meaning that if I screwed up, that needle will peg, and from that point on, the meter, throw it out into the garbage. So now, remember I said once in a while, I might ask you to look at something different. I'm going to take this, and I'm going to switch my pocket back. And I'm going to put it on my volts. I'm going to switch my meter. I'm going to put it on volts. This time, I'm going to hook it up. What, guys? Here's my load. I'm going to hook it up in parallel. Does that make sense? I can turn this on. Okay. Reading voltage. More voltage. I'm increasing the speed, guys. You can see the flag over there. More voltage, and more voltage. Now, I'm not dropping everything because keep in mind too, I might not have done the best job with connections, but you get the idea. Look, this stuff, what I just did, to be honest with you, the way I usually try to explain it is that if you understand what you're doing, go into the fuse or whatever. I'll show you a fuse in a second here too on a relay. I'll use an amp clamp probe. Customer comes in and says, you know what, something changed. I'm not getting it just doesn't seem to be blowing like it used to. It goes through the speeds, but it isn't, I don't, because after all, the customer is the best person to know if something changed, right? So you're going to go over there, you're going to mess around, and you feel, gee, it's got voltage. I put my test light there, I put my ground in here. It's got to be the motor. Maybe it's just weak, So you go through all the trouble, get at the motor, change the motor, and it's like you're over there, you're listening, it does kind of change speeds. Give it back to the customer. Customer says, well, that didn't do the trick, Instead of actually just sit in there, sit in a cab, wherever you can get a hold of any fuse or whatever, or if there's a harness, we're going to get at that. Sit there, have a cup of coffee. Whoop, something was beeping. Have a cup of coffee. Diagnose it that way. At least you're going to diagnose it. I know this should draw X amount of amps through all the different speeds. It's not doing it. So if it's not doing it, shame on you. Bobby, I hate to do this, but back me up again. Back me up. Can't remember which hand was resistance. Okay, resistance, low, amperage high, electrical resistance high, amperage low. Okay, all day long, Ohm's law. Now, I use this meter here. We're going to do one more thing over here, okay? I will pop this out of here, okay? And let me shut this off. I am gonna put this in here, okay? If you zoom in, that's close enough, okay? Talk about sitting in the cab, okay? So you go in there, wherever you can get at the relay, and I am gonna turn this on. This is my N2, okay? I will put it on 20 amps direct, okay? I'll put this around here. I'm gonna try to find a spot so I'm not in the way over here. Wrap it around my wire. I'll zero it out as best I can because I'm in a hurry here, okay? And I turn this on. Oh, sorry. I turned this on. There you go. Basically, I'm turning on the control circuit, okay? So I'm putting it through the paces, and you can see the amps here. Are you zoomed in? That's nice. Now, I like this reading here, okay? To be very honest on this N2, and I can go up high, because what happens is, if you can see that, I mean, it's about as direct as you can get, okay? Because I do have other amp probes, okay? And shoot over here. Now, this here, I can stick in my regular digivolt ohm meter. I'll pull this off because we're going to wrap it up in a second here. Okay? And basically, I'll just stick this in here like this, and I'll put this around. I got my cable wound up, you know, and I turn it on millivolts, okay? And what happens with this one here is I'm going to have to do a little math over here because when I turn it on, it all depends, you know, I got to move the decimal point. Is it 1 millivolt, you know, moving more towards the amp probe here a little bit, okay? And you can see my dial over here, I'm switching around, okay? These are nice. Now, I do have a few other ones, and they're all nice tools, guys. Okay? This one is nice, and I'll tell you why. I have, where is it? I have this one here, okay? Now what happens is I do have leads to measure volts and stuff, but I want my amp here. The problem with this one, as nice as it is, you can picture and back up a little bit here, okay? So picture this is your engine compartment, you're trying to get into harnesses. This is where you pick up the reading, okay? So what happens if it got to reach real in, and I got to tell you, I do stretching. I'm into Taekwondo and everything else, and I think I'm very, very physically capable of doing a lot of stuff, but I'm not a contortionist. I might have a hard time getting in there. So versus this here, you know, with the long lead, I can put this amp probe, you know, wherever, and my meter is way up here, if that makes sense. There are other ones. You know, if I wanted high amperage, fluke over here. I'm just pointing out tons of stuff. So anyway, oh, you get a kick out of this. So here I got this, let me shut this off. Here I got this, this is good. Here I have this, right? The fancy one. It comes in a kit. Get them for every kind of a relay that's known to mankind, you know, pretty near. They are great. Because basically the reason I want to do this is if I have an issue, is my issue really, you know what, I need to get in there fast. Is it a control issue, you know, or is it, you know, someplace else? And if I get this going like this, because I'm using the control here, I'm eliminating the I'm saying that, you know what, I have a control issue because I'm actually taking the place of the control. But anyway, so here, this is what I want you, years ago, okay, G and Ralph Birnbaum, they did they had what they call a book called, and I don't know if G will remember his own book, okay, and they had this kind of a silver bullet thing, and I got this from there. So what basically is, okay, I put it on plastic, I still show the guys, okay, gives you the configuration of the relay, and all this is well, my wife doesn't look at the video, so I wanted to build one here. So I took a basically cord from a coffee maker, twisted it over in the same shape as I would need to put in my control circuit. Man, my wife was mad forever. For about a week she was looking for it, and of course, come on guys, you know, you play stupid. I don't know, you must have left it something. Just kidding. But I also put a switch in there to control it. So when I first put this together, next to me there's a trucking company. Driver got through at the end of the day. He had a brand new Ford, okay, and he comes in, we're trying to leave. He's been out on the road a couple of days, and his car doesn't start. So he says, geez, I gotta. So I says, well, we're trying to leave. Go ahead, we'll walk out to see what you got. And what happened was, it was a relay for the fuel pump, but it wasn't the fuel pump relay. It was controlled to the fuel pump. So I went out there, I says, you know what, let me pop that relay off, you know, for the fuel system. I popped this in there, turned this on, and it started. So he says, man, he says, I guess I'm going to have to take it to a dealer. He says, I don't want to, it's easy. I got to wait for a tow truck. I am so beat. So I looked at the guy, says, listen, I says, I'll tell you what, keep this on there. This turns it on and off. Go home, shut it off, okay? In the morning, when you had your good night's sleep, turn it on, drive it to a dealership, and like I'm worried about a $2 little thing here, I says, do me a favor, bring this thing back, you know? So he goes to the dealership, he comes back a day later, brings it back, he says, when I showed them how to start this thing, it blew their minds over there. So, gee, I gotta tell you, it worked. So,
Thanks, Swede.
yeah, yes, I am doing that. I'm looking for my clicker. I see it. You know, thanks for the reminder. You know, look, this is just the beginning of our journey. Next few Lunch and Learns, we're going to continue with this diagnostics. But you know what? I'm going to actually input some other type of stuff too. Look guys, we got tires, we got all sorts of different areas we can work. It's a commercial motor vehicle, you know, no matter what you work, it's on diagnostics, you know. So, oh, you need to see this. One last thing. I have over here, okay, this is a Cummins. This is an engine, those of you who work at. Here is my coolant bottle over here, okay? And I have my little thing to see if we got compression leaks. You can see over here we get a compression leaks. So now, I'm gonna give you guys something to think about. I'm gonna back up, take a look at this truck here one more time, okay? Everybody happy with that? Now watch this. Yeah, they told me I'm a little flaky, there's something wrong with me. But you can see the flames coming out of there, venting out of there. So, what do you think was going on? Just think about that. Any questions? I know Chi was handling them. I did not get to that point, and again, I really gotta apologize for the first 10 minutes, okay? I see stuff on the handouts and everything else. The last thing, guys, this, I'll keep it on for a second so you guys can take a picture of this QR code, okay? Please take a picture, fill out a quick survey, put on whatever you want. If you think this sucked or whatever, it's okay too. We need to learn. But know one thing, you know, hold on a second. Somebody said combustion gas in the cooling system, combustion chamber pressure. Good thoughts. Good thoughts, you know. So anyway, look guys, it is a few days away from Christmas. You can back up, you know, they need that. Yeah, I'll leave that QR code. I really want to wish everybody here a Merry Christmas, a Happy New Year, and if you prefer Happy Holidays, that's okay, you know, but a lot of you guys know how I roll, so, you know, we're all in the same boat, you know. Oh, wow. Wow.
Well,
CNG, hold on. CNG injector leaking past C. You are so close. You are so close. So good thinking on there. So thank you guys, and hopefully G will have this posted so everybody else can see this, you know. And thank you again. I really truly appreciate that. Okay.
We want to thank you, everyone out there. Of course, without you, these things would be nothing. So again, Merry Christmas, Happy Holidays, Happy New Year. It will be up, part 2 and 3 and more coming up next year in 24. Everyone enjoy. And Swede, thank you again, my friend. Great job.
Thank you, G, for allowing me to do this. And thank you guys for even watching, because that really gets me pumped up. Thank you.